Okay, so welcome to lesson 6. In this lesson, we're going to explore overriding member methods. We're going to create a derived class from a base class and then write some tests to explore how all this works. Let's get started. So this should be fairly straightforward. The only thing that we're actually going to be implementing here is the fiction class. The book class and the book test is given to you, and I will show you the fiction test as an example. So let's go over what we're doing. We are going to create a fiction object, a fiction class that can represent a fiction book, and it is going to extend the book class in book.java. Then you're going to override all of the methods of the book class in the fiction class itself. So it will return the correct data. For example, right now, if you look at book, all it does is return none for title, none for author, none for ISBN, none for genre, etc. Right? So we have to make sure and return a title, author, ISBN, and genre in the fiction class. Now, notice you can't modify this class at all. You can't add any member variables. You can't do anything. Everything must be done in the derived class. Okay. Additionally, you need to create a constructor for the fiction class that takes the following signature so that everything will work. Now, once you have that finished, we want to write some unit tests for the fiction class to make sure that everything is working, and then complete the retrospective and add commit your push code as always. So let's talk about something that's kind of weird in this this project, and you're going to see this a lot in these type of labs. Explore how to program without ever writing a main function. So in industry, when you've got an industry, writing small little executables all the time is not going to be your primary job. Yes, you will write, small little executables for your utilities or, testing or what have you, but most big programs are implemented in the form of a library, meaning that there is no main. Everything is just a class. And somewhere deep down in your project, somebody wrote a main years and years ago, and all it does is just load up all the rest of the code. So honestly, like having a main function is not that important, and not really, it's actually pretty rare in industry. I know in my experience, I've never written an actual main function to be used in production code, right? Like meaning that all the stuff I've worked on, the actual main was written, 30 years ago, and it hasn't been touched since. So you might be wondering, well, if there's no main, how does it run? Well, there is a main, okay? It's just provided to you by the testing framework, right? So when we write our tests in book tests and fiction tests, these tests that we have are part of a framework, and that framework has a main function somewhere deep down in the testing framework. So we can actually go look at here, and we can say testng right here. Okay, so we're using the testng framework, this test implementation. So this testing framework has the main somewhere deep in its inner bowels somewhere. Okay, so why is this important? Well, it's important because this style of programming forces you to write unit tests, and because that's what you're going to be doing in industry. You can't just run it on the command line, right? There's no way to just run this on the command line because the main is gone. So the only way to run this is to go over here and to actually run it. Now, you see I have all green, but I've made some changes. So let's actually run this again. I'll probably have an error. Oh, looks like I fixed everything. So now I have the default test suite. I have 2 passes, 0 failures, 0 skips, right? So everything looks good. I can also run it on the terminal, right? I can say great alt W, and I can say test. And eventually, there we go. And everything passed. right? So it was taking a long time to start up because I haven't run the testing in a while, but the second run should go fairly quickly. See, you look at that. See how it goes a lot quicker on the second one. So so right there is that's it. Honestly, that's a lot of computer science in a nutshell. That really, honest to God, that is what you're going to be doing a lot of the times. Is you write your code. We go and write we write fiction, right? We write that class, and then we go and write some tests. Then we go over our testing framework and we write, and we just hit go, run the tests, and things pass. So that's it. So we can actually go and let's play around. Let's make this let's make this wrong. Let's just add E, and we hit that, and now we can go back over to our testing, and we can run, and it should see a failure, and right there, see, assertion error, expected title E, but found some title, right? See, I added an E, assert fail, so it tells me, right? And you can see, look at this. If we look at the stack trace, you can see down here, look how big this stack trace is. So look at that. There is the main. Run launcher main, and it's actually probably below even that. So because this is actually still in the you can see this is still in Microsoft code, which is probably executed from VS Code, because VS Code is a Microsoft project. So the main is probably somewhere in run. This is probably a thread, suite runner, test runner. Would be my guess. Test method worker. Yeah, so these are all threads. This is all threads. I haven't actually looked at the internals. I'm just making my best guess by looking at this stack trace. So you can see that down here, the main is somewhere down below the launcher. So somewhere probably in here is where a main method exists to get us running. So that's pretty cool, right? That is what allows us to write code and write it without having to constantly test our manual process, with like just running a command line app. So let's fix that. Let's go run this again, and we should be good to go. Now, you may ask, why would I ever want to do this? Instead of just running a main for the command line. Well, this setup that we're doing here with unit testing and running the test and not having a main at all allows for automation, right? This can all be run on a server. It doesn't require somebody sitting in a terminal. So imagine that you have 10 million lines of code, and you have 10 million lines of, and you have 10,000 tests. You're not going to sit there and run test after test after test manually, right? If you have 10,000 tests, you want to click a single button and go, done, run all of my tests. And that's what we're trying to do. Even though we have 2 tests right here, right? So this is definitely overkill for what we're doing, but we want to think in terms of what we'd actually be doing in industry. So, okay, so I want to be really clear here, because I don't want any confusion. Every program needs a main somewhere. You've been taught that in 121. It remains true in 221. I'm not saying that we can eliminate the main. Every executable has to have a main. You have to have somewhere to start. What I'm saying is, with this project setup that we went over, is that in industry, you won't be the one that typically writes the main, right? The main will be somewhere else. You typically are going to be writing what's called library code, which is just classes. There's no main method. Okay, when you go and package and build your application, whatever company you're working for, the packaging and building process will likely provide the main for you. Okay, so in our case, the main is being provided by the TestNG framework. So I know it's a real subtle difference, right? And I just don't want anybody to think that, all of a sudden now you can, not have a main. That's not the case, right? We all have to, all programs have to start somewhere. What I'm trying to show you is that there's libraries that provide that for you, which is what you're going to do in industry. So I hope that makes sense. I hope that's clear. If not, jump on the discussion boards. Let's talk about it. But I really think that if you start this habit of not putting everything in main, just writing your tests, writing your libraries, writing unit tests, your code will be infinitely more robust. Your grades will be higher, and when you get out into industry, you'll just be a better engineer overall because your code that you write will have fewer bugs than other engineers that don't test. So hopefully that makes sense. Again, I post any questions you have, and I look forward to interacting with you guys all online.